I'm also going to begin the whiteboard. Classic whiteboard. There we go. Okay, so we have a quiz that goes up today at 12 p.m. and then one that closes at 2 p.m. today. So you have two remaining quizzes. We have an extra credit activity that we will do tomorrow, which will be 8/1. We'll do that at the beginning of our class period tomorrow. So those items all remain. Now, I am in the process of writing the exam. I'm just under halfway through, and I can tell you that your final will be 50 questions, and you will have 120 minutes to complete it. With respect to your final exam, the final exam is a great opportunity to replace a previous exam grade, because it can be and it will be compared to your previous exam grades. And if your final exam score is higher than your other exam scores, then your final will replace that. Now, what I wanted to talk about primarily today was, because of the fact that sections 8.1 and 8.2, we talked about those yesterday. You're going to have quizzes over those, but you're not going to have a standalone exam over that. But instead, you're going to have questions on your final that relate to 8.1 and 8.2. Now, this is a section that's a little bit, it presents challenges. It's kind of challenging because we talk about it in a couple of different ways. There's kind of base level questions that are almost, do you know the definition of, or do you know the definitions that are relevant and important for 8.1 and 8.2, but then also can you apply those definitions? So when it comes to 8.1 and 8.2, there are a couple of important terms that you need to know. One of them is oxidation. Another is reduction. Then you also need to know when something is oxidized, it undergoes oxidation. So is oxidized. When something is oxidized, it is the, and this is where it tends to get a little bit confusing. I'm going to say reducing agent. So then if something undergoes reduction, it is reduced. When something is reduced, it is the oxidizing agent. Now, those two separate ideas kind of have two sub-ideas below them. But before that, you have to understand what oxidation is. Oxidation is the loss of, and I'm going to write E minus, or electrons. Reduction is gain of E minus, or electrons. So you should expect approximately 10 questions on your final exam that relate to all of this right here. Now, when it comes to those 10 questions, are you going to have two standalone questions that are this and this, putting together the definition? Probably not two, but you'll probably have one question that just explicitly asks, kind of fill in the blank. Oxidation is blank. But then what I want to do quite a bit of is have questions that show a chemical reaction. For example, let's go with Mg plus HCl. This is magnesium solid plus HCl, which is aqueous, so that's an ionic solution. That's going to produce hydrogen gas plus Cl2. So this is the sort of question that I like to use, and I will use on the final. That's kind of, it's multiple levels. It's asking you to do multiple things. One thing that it's asking, that I might ask you to do, is balance this chemical reaction. In which case, you can look at all of the different substances on the reactant side and on the product side and kind of deconstruct it and say, okay, well, there's one magnesium. Okay, there's one magnesium. We're balanced there. Great. Hydrogen. There's one hydrogen. There's two hydrogens. That presents a little bit of a, if nothing else, an imbalance. They're not equal to one another. How can we resolve that issue? Well, we can't change a subscript, but we can use what's known as a coefficient. So I'm going to put a 2 there. Okay, so now I've got two hydrogens on the reactant side and two hydrogens on the product side. What does that also do? This 2 means that now I have two chlorines on my reactant side, and I haven't looked at the chlorines on my product side. But lo and behold, I'm good. I've got 2 over there. So I'm happy with that. Now, where it gets a little bit tricky is I am going to basically be asking a couple of different things. Which species gets oxidized? And then which species gets reduced? Okay. So the species, if we were to bounce back, we'd say the species that gets oxidized undergoes oxidation. And something that undergoes oxidation loses electrons. Something that is reduced undergoes reduction. Okay. Now let's look at this and say, well, which of these species gains or loses electrons? Now, what we need to do in order to answer this question is be able to calculate the charges of all of these different species. First of all, we'll start with our reactants. That's what we always want to do because we're reading from the left to the right. So our first species that is identified is magnesium. What's the charge of magnesium? Well, since it's listed as Mg with that subscript of solid, or that S subscript, this is known as being in its elemental form, and so it has a charge of 0. Okay? Because if there's only one of those there, it's not like, oh, well, it's listed as 0 because if you look in the upper right-hand corner of that symbol, there's nothing there. Okay, so this is our species which has a charge of 0. Now, what we want to do is we want to identify magnesium on the product side. So it's a 0 on the reactant side. Where is it on the product side? Is it still a 0? Well, if we look over here, we see that magnesium is a part of a compound, MgCl2. Now that MgCl2, that's one of the products, and I would give you that. But you would be able to see, okay, whenever I look at MgCl2, I don't see a charge indicated, so I'm going to go ahead and operate under the idea that this has a charge of 0. Okay, so if that has a charge of 0, how am I able to put this together? Well, what this tells me is that the magnesium and the 2 chlorines, those three atoms have charges that collectively, that they add up to 0. Now, how is that going to be? Well, one thing that we can do is we can look back at the periodic table, and I will pop this up. Share my screen with the periodic table. And I can see that Cl, which is what we're looking for, is right here. It's in this row of the periodic table. Specifically, it's right here. Now, these elements that are in row 7, their most common ion that they like to form is a -1 ion. Okay, so now Mg, we can also look at that and try to deduce it. Mg is right here. The elements in this column right here have a +2 charge. So we're looking at species that have a -1 and a +2 charge respectively. There we go. So if Cl has a -1 charge, and there's 2 of them, I like to write it like this: Cl minus, Cl minus, and then Mg2 plus. Effectively, that and that give me charges that add up to 0. So 2 minuses and 1 positive and 1 plus 2. So we get that charge of 0. So what that means is magnesium here. Let's write that charge. It is +2. Cl is -1. I'm going to write that down because that might become relevant in just a little bit. Now, I'll give you a couple of seconds. Does anyone have any questions where I got those numbers from? Okay, great. So this addresses magnesium, which has gone from a 0 charge to a +2 charge. Now, what does that mean? Have I gotten oxidized or has it gotten reduced? Well, the way that I always like to do this is I like to think about it as, here's just sort of an electronically neutral atom. In its nucleus, let's go ahead and just say that it has 3 protons. Now, those 3 protons, magnesium has more than that, but let's just imagine that we have a magically made up element that has 3 protons in the nucleus. The way that I've depicted it right here, I have my 3 protons. How many electrons have I drawn? And this isn't a trick question. Have I drawn any electrons? No, I haven't. So since I haven't drawn any electrons, what's the charge of this ion right here? Well, it has 3 positive charges, no negative charges, so it has a charge of +3. Now, if I were to draw 1 electron right here, now it has a +2 charge. Let's go ahead and throw another electron in there. Oh, now it has a +1 charge, and then a third electron, and now it has a 0 charge. So now what I have effectively, we kind of reverse engineered. Here we have a completely neutral atom that has 3 positive charges, and those 3 positive charges are counteracted by 3 negative charges. When we lose 1, so that atom that I've drawn, and now this resulting ion, what has happened to it? It has lost 1 electron. So it has gotten oxidized. So going from a neutral charge to a positive charge is where we see oxidation take place. So if I want to complete this and show, Okay, something going from no charge to a +2 charge, it still gets oxidized. So now I'm going to erase my ion there. So what we can say is that if you go from neutral to positive, that is the species that gets oxidized. So I can say magnesium. Magnesium gets oxidized. Okay. Does anyone have any questions about that? All right, so we've identified our species that gets oxidized. So what that means is we can bounce back. If we've identified our species that gets oxidized, we've identified our reducing agent. So I'm going to use a different color, and I'm going to say this is my, or magnesium is my, this sounds like it's out of a James Bond or something like that, or a Cold War era book, a red agent. But I'm talking about a reducing agent here. Okay, now the trickier part is what gets reduced. Well, in this case, we can't really say, oh, well, it's HCl that gets reduced because HCl is a compound. So a compound is unlikely to get reduced, but instead the parts of that compound or one of the parts of that compound are what are going to get reduced. For example, we have H and we have Cl. Now, we did a calculation earlier and we figured out that the charge of Cl is -1. Now, where some folks get a little bit mixed up is they see MgCl2 and they think, actually, I can do this on another page. It's more clear if I do it on another page. What they make the mistake on is they say MgCl2, and I don't know if I can do a subscript here. Okay, that's fine. Is equal to Cl. Now I'm going to switch to the pen. MgCl2 is equal to Cl2. And they say, oh, well, it's both Cl2. And I know that chlorine gas is a diatom. And it's a diatomic element, so Cl2 does that. That is incorrect. That is not true. This right here, this chlorine in this compound has a charge of -1. Now, when we look at chlorine over here on the reactant side, we have HCl. That is a compound with an overall charge of 0. Hydrogen is rolling in with a charge of +1. Chlorine counteracts it with a charge of -1. So plus and minus, that's where we kind of arrive at a compound that has a neutral charge. Now, when we look at H2 as one of our products, now I didn't include this, and it doesn't really change the result, but we would have a G there because this is in its gaseous state at room temperature. So that H2 gas, that is one of our H Broncliffe diatomic elements, HBronclif. These are all diatomic elements, so that means 2 of them pair up to give an overall, or to make a compound. That compound is going to be neutral, electronically neutral. It has an overall charge of 0. Now, what that means is that this H2 has a charge of 0. So effectively, what we've seen here is Cl, it's negatively charged. It's negatively charged. And the magnitude of that charge is -1, and it's -1. So the charge of chlorine does not change at all. Hydrogen, on the other hand, it's positive, and then it's 0. So in this case, that is something that is changing electronically. So if we were to draw an element that has, let's see, a positive charge, there is our O, that's our ion. This is our hydrogen that we started out with, and then it gets an electron. Now what's the charge? Neutral. Overall charge of 0. So what we can do is we can say our reducing agent is hydrogen. So this went from positive to neutral. This is, since hydrogen gets reduced, it is the oxidizing agent. So I think that a really good way to look at this is to think about it like this. Neutral to positive is oxidation. Positive to neutral is reduction. Then the next thing that you need to keep straight is that, let's see, there we go. Is that the species that gets oxidized is the reducing agent. The species that gets reduced is the oxidizing agent. If you keep that straight, you're going to be in very good shape for this, these kind of 10 questions. Now, I think that a very good strategy to have when it comes to thinking about questions about oxidation and reduction. And I'm going to show my hand a little bit, but I don't really mind doing that. We can put together basically 10 questions or a couple of ideas, maybe not 10, because it will take, I spend a little bit more time putting together an exam. But when it comes to questions about, or ideas of questions about oxidation and reduction, one, a definition of oxidation or reduction. That's a fair question. That's just an explicit, what's the definition? Which is the one that loses and which is the one that gains electrons? Then, definition of oxidizing agent, reducing agent. Then, because those two questions are distinct from one another, you might be able to put together or remember what oxidation or what reduction is, but you might get mixed up on oxidizing agent and reducing agent. What I would recommend is remembering that the species that gets oxidized is the reducing agent. So, and vice versa. Next is application of oxidation reduction. Application of oxidizing agent, reducing agent. So here I'll give you a balanced chemical reaction and I'll ask which species is getting oxidized, which species is getting reduced. So I would actually venture to say, oh, what? No, just a second. Sorry about that, everyone. Oh, that's not what I wanted. Go. Okay. So there we're looking at approximately 6 questions. So what I would do is give you a balanced chemical reaction or a series of balanced chemical reactions and ask you which species is getting oxidized, which species is getting reduced, which species is the oxidizing agent, which is the reducing agent. So these could come in the form of balanced chemical reactions, but they could also be looking at specific models or looking at models like something like this. X plus an electron yields X minus. Or a good question would be something like, a symbolic reaction oxidation or reduction. So that symbolic would be something like, which of the following is an example of oxidation, which of the following is an example of oxidation? X plus E yields, sorry, that would be X plus E minus yields, let me clean that up just a little bit. X minus X minus plus E, and then X yields X minus plus E, and then let's see what's another good option. X minus plus E minus yields X. There we go. So these would be, answer options A, B, C, and D. So the question for this would be, which of the following answer options displays oxidation and accounts for all the different charges? Okay, so which of these displays oxidation? So then what you would have to do is you'd think about, okay, oxidation is the loss of electrons. So what that means is that on my product side, reading from left to right, my species that's displayed on the left is going to lose an electron. So what that means is that an electron is going to be one of my products. Because if you let's look at answer option A. A shows a substance, X, plus an electron. That's gaining an electron. So this right here would show X gaining a negative charge. That is an example of reduction because X gained an electron because we read from left to right. Now, D, okay, well, D is wrong for a couple of reasons. One reason is that X minus gains an electron. What is the charge of an electron? It's a negative charge. Our product, therefore, should be 2 minus. So the closest that this would be to reduction, but we have a charge issue there. Our overall charge is the problem, or is one of the problems. The other is that we have an electron being added to whatever species we have on the left-hand side of the reaction. So answer options A and D are out. Okay, crossed out. Now that leaves B and C. Okay, so if we look at C, we have X yields X minus plus an electron. Okay, so an electron is on the product side. So that makes C partially correct. But if something is going from neutral and losing a negative charge, then it should have a positive charge. So this is out. So C is out for that reason. By process of elimination, B is our only correct answer, but we can also confirm that B is the correct answer and our best answer because of the fact that we go from X, which is neutral, to X, which now has a positive charge, and an electron on the product side. So we have something that is no charge and then positive and negative that come together to give us that overall charge. So our correct answer for this one would be B. That to me is a good question, and a question that maybe it was foolish of me to go ahead and say in a review session because of the fact that I mean, I could mix that question up and make it about reduction as opposed to oxidation. But that's a good question because it asks a couple of things. Can you reconcile or balance the charges? Are you accounting for that? Is that species gaining or losing an electron like it should be? There's multiple ways that your answer options can be wrong. So that gives you good answer options. Then, of course, I'd throw in the bottom there, like E, all are correct or all represent oxidation, and F, none of them represent oxidation, just to kind of be like little curveballs there. So these were really the high points. And I think that, you know, if anything, when it comes to oxidation reduction, these are the sorts of questions. I'm going to put together 10 total questions, but this gives me a root of basically 7 questions. These 4 that are highlighted in red, oh, oopsies. These 4 that are highlighted in red in the middle, I don't know why. No, I don't want that. The 4 that are highlighted in, okay, now I'm going to stop. There we go. Questions or prompts 3, 4, 5, and 6. That is this. That is identify what gets oxidized, what gets reduced, what is your oxidizing agent, what is your reducing agent. And a little bit of a spoiler alert. In a chemical reaction, one thing can be, it is possible for an element to be an oxidizing agent and a reducing agent. So what that means is both gets oxidized and reduced. That is possible. Should you expect to see a question like that on your exam? No. Can balanced chemical reactions be infinitely more complicated than what we're looking at right here? Yes, they can be infinitely more complicated. Is that what I'm going for whenever I provide you with a balanced chemical reaction? No, it's not. What I'm going for is, do you understand what's happening? Or do you, basically what I'm looking for is, and what I'm trying to get at is, do you understand the rules? Good. Do you understand every exception to the rule? No? Well, that's not what I'm looking for. I'm looking for, do you understand the rules of the game? So you can say which is an oxidizing agent, which is a reducing agent, which gets oxidized, which gets reduced, and so on. I'm going to go ahead and stop right here because tomorrow we're going to do our group work activity and our extra credit opportunities. In addition to that, I'm going to go over some of the high points of the first 4 exams and what you should think about with respect to those. That's going to be relatively brief, just because, like, at least for the first 2 exams, it's going to be fairly brief. But then after that, it might take a little bit longer. But I'm going to go ahead and stop my recording and stop my share. If anyone has any questions, they're more than welcome to hang around for a little bit and